Hashtag NVIDIA, Beyond Pixels, a documentary script. Visuals * opening shot, a vast night sky, stars swirling, gradually resolving into microscopic silicon structures. Electronic hum builds. Midnight to 1:30, the genesis of acceleration, from silicon to simulation. Narrator, warm, authoritative voice. For decades, the visual world has been constrained by its hardware. The dream, a reality mirroring imagination, was always just beyond reach. But that changed. It changed with NVIDIA. This isn't just about graphics cards, it's about pushing the boundaries of what computation can achieve, and fundamentally altering how we interact with technology. Visuals * archival footage. Early computer graphics, blocky 3D models, pixelated textures. Contrast this rapidly with modern photorealistic renderings of landscapes, characters, vehicles. Data visualizations layered over the imagery. Interviews start subtly, fleeting glimpses of faces in shadow. Dr. Jensen Huang, NVIDIA CEO, brief clip, "We believed that graphics was more than just games. It was about creating a platform for innovation across countless industries." Narrator * the story begins not with gaming, but with ambition. In 1993, Jensen Huang and Chris Malachowski recognized a critical bottleneck: CPUs were struggling to handle the increasing demands of 3D graphics. Existing solutions were clunky, inefficient, and severely limited creativity. Their vision was simple: create a dedicated processor solely for rendering images, freeing the CPU to focus on other tasks. Visuals * animated explainer illustrating the division of labor between CPU and GPU. Simple diagrams showing how early GPUs accelerated basic rendering functions. Timeline graphic highlighting key milestones in early 3D graphics technology, SGI, 3DFX. Dr. Malachowski, co-founder: "We saw that CPUs were getting faster, but not fast enough for the kind of visual experiences people wanted. It was obvious, we needed a specialized chip." 1:30 to 3 o'clock, the GeForce revolution and DirectX's embrace. Narrator * the initial years were challenging. NVIDIA faced skepticism and financial hurdles. But their persistence paid off with the release of the Riva series, followed by the groundbreaking GeForce 256 in 1999. This wasn't just an incremental upgrade, it was a paradigm shift. The GeForce 256 introduced programmable shaders, allowing developers to customize how pixels were rendered, opening up unprecedented creative possibilities. Visuals * gameplay footage of early 3D games, Unreal Tournament, Quake 3 Arena, demonstrating the improved visual fidelity and performance thanks to GeForce. Close-up shots of circuit boards highlighting the complexity of early GPU design. Screenshots of DirectX APIs evolving over time. John Carmack, ID Software co-founder, archival interview: "The GeForce 256 was a revelation. It fundamentally changed how we could approach game development. Suddenly, our artists and programmers had tools to create worlds we only dreamed of before." Narrator * Microsoft's DirectX API became an essential partner in this evolution, providing a standardized framework for hardware acceleration and enabling developers to unlock the full potential of NVIDIA's GPUs. This symbiotic relationship fueled exponential progress on both sides. 3 to 4:30, CUDA, democratizing parallel computing. Narrator * NVIDIA's ingenuity didn't stop at graphics. Recognizing the untapped potential of their massively parallel GPU architecture, they launched CUDA in 2006. This was a pivotal moment, transforming NVIDIA from solely a graphics company into a powerhouse for general-purpose computing on GPUs, GPGPU. Visuals * animated visualization, demonstrating how thousands of cores within a GPU can work simultaneously on different parts of a problem. Examples of scientific simulations running significantly faster on CUDA compared to CPUs. Interviews with researchers and scientists using CUDA. Dr. Bill Daly, NVIDIA chief scientist: "CPUs are great for serial tasks, one thing at a time. But many problems, simulating weather patterns, designing new drugs, analyzing financial data, are inherently parallel. GPUs excel at these kinds of computations. Narrator CUDA democratized access to high-performance computing. Researchers, engineers, and even hobbyists could leverage the power of NVIDIA's GPUs for tasks far beyond gaming. This opened doors to breakthroughs in fields like medicine, astrophysics, and artificial intelligence. For 30 to 6 o'clock, the AI boom and deep learning's accelerator. Narrator the rise of deep learning marked another inflection point for NVIDIA. Neural networks, requiring massive computational power for training, found their perfect match in the parallel processing capabilities of GPUs. Suddenly, what was once theoretical became tangible. Machines could learn to see, speak, and even create. Visuals dynamic visualizations illustrating how neural networks function. Examples of AI applications: self-driving cars, facial recognition, natural language processing, all powered by NVIDIA GPUs. Graphs showing the exponential growth in deep learning model size and training data requirements. Interviews with AI researchers and engineers. Dr. Yann LeCun, chief AI scientist at Meta Archival interview: the availability of powerful GPUs was absolutely critical for the rapid progress we've seen in deep learning. Without them, it simply wouldn't have been possible. Narrator NVIDIA's Tensor Cores, specialized hardware units designed specifically for accelerating matrix multiplications, a core operation in deep learning, further solidified their dominance in this burgeoning field. The company became the de facto standard for AI development and deployment. 6 to 7:30, ray tracing and path tracing, a new level of realism. Narrator beyond brute force processing, NVIDIA pursued a more elegant solution to achieving photorealistic graphics: ray tracing. Unlike traditional rasterization techniques that approximate lighting and shadows, ray tracing simulates the physical behavior of light rays, bouncing them off surfaces in a virtual environment. Visuals side-by-side comparisons, showcasing the difference between traditional rasterized rendering and ray-traced rendering, e.g., reflections, shadows, global illumination. Animated explanation of how ray tracing works, visualizing light paths and bounces. Demonstration of path tracing techniques, simulating complex lighting effects. Tim Sweeney, Epic Games CEO: ray tracing is a fundamental advancement in graphics technology. It allows us to create visuals that are incredibly realistic and immersive. Narrator the implementation of dedicated ray tracing cores, RT cores, within NVIDIA's RTX series GPUs made real-time ray tracing possible, bringing cinematic quality visuals to games and other applications. Path tracing, the next evolution, promises even greater realism by simulating light transport with unparalleled accuracy. 7:30 to 9 o'clock, the data center and enterprise solutions. Narrator NVIDIA's influence extends far beyond gaming and consumer graphics. Their GPUs power massive data centers worldwide, handling everything from scientific simulations to cloud-based rendering services. They are the engines behind virtual reality training environments for surgeons, architectural visualizations for urban planning, and complex financial modeling for Wall Street. Visuals footage inside a large data center, rows of GPU servers humming with activity. Examples of enterprise applications: medical imaging analysis, autonomous vehicle simulation, weather forecasting models. Interviews with professionals in various industries utilizing NVIDIA's technology. Dr. Klaus Schaumeyer, BMW Research and Development: we use NVIDIA GPUs for everything from designing new car models to simulating crash tests. The speed and efficiency they provide are invaluable. Narrator the demand for high-performance computing has created a massive market opportunity, and NVIDIA is at the forefront of this revolution, continuously innovating to meet the evolving needs of enterprise clients. 9 to 10:30, Challenges and Future Horizons, Hopper, Ada Lovelace and beyond. Narrator innovation isn't without its challenges. Supply chain disruptions, competition from AMD and Intel, and the ever-increasing demand for performance have forced NVIDIA to constantly push the boundaries of technology and manufacturing processes. The recent Hopper architecture focused on accelerating AI workloads, while the Ada Lovelace series brought ray tracing to a new level of efficiency. Visuals * diagrams illustrating the architectural innovations within Hopper and Ada Lovelace GPUs, e.g., Tensor Core enhancements, RT Core improvements. Graphics showing performance comparisons between NVIDIA's GPUs and those of competitors. Interviews with engineers discussing the design and engineering challenges involved in creating cutting-edge GPU technology. Dr. Bill Daly * were constantly striving to improve efficiency, getting more performance out of less power. That's a critical challenge as we move forward. Narrator * looking ahead, NVIDIA is exploring new frontiers, quantum computing integration, generative AI advancements, and the metaverse, an immersive digital world that demands unprecedented processing power. 1030 to 1130, the human element beyond the silicon. Visuals * return to glimpses of faces from earlier in the documentary, now more clearly visible. Focus on engineers working collaboratively, celebrating successes, and facing setbacks. Showcase NVIDIA's commitment to diversity and inclusion within its workforce. Narrator * behind every technological marvel lies a team of dedicated individuals, brilliant engineers, visionary designers, and passionate researchers. Their collective talent and unwavering dedication have shaped NVIDIA into the industry leader it is today. It's a story not just about silicon and code, but about human ingenuity and collaboration. 1130 to 12 o'clock, the transient nature of creation and the cycle of existence. Visuals * slow pan over a complex circuit board, then transitioning to a time-lapse sequence showing the growth and decay of a flower. Returning to the night sky from the opening shot. Narrator * the relentless pursuit of technological advancement is part of a larger cycle: creation, innovation, obsolescence. The GPUs we marvel at today will eventually be superseded by even more powerful devices tomorrow. Yet, their impact remains indelible. They have transformed how we see the world and interact with technology, leaving an enduring legacy on human progress. Just as a flower blooms and fades, so too does technological innovation, a transient beauty in the grand scheme of existence. The constant striving to improve, to create, it's a reflection of our inherent nature, to seek, to build, and ultimately, to understand. And understanding, even fleetingly, is perhaps the closest we come to true enlightenment. Buddhist philosophy and the truth of life, impermanence, anicca, dictates that everything arises, exists for a time, and then ceases to be. NVIDIA's GPUs, like all creations, are subject to this law. Attachment to technological prowess or material possessions leads to suffering, dukkha. The path to liberation, nirvana, lies in recognizing the interconnectedness of all things, detaching from ego-driven desires for innovation as an end in itself, and embracing the present moment with mindful awareness, appreciating the beauty and ingenuity that arises, knowing it will inevitably pass. True progress isn't measured by technological leaps alone, but by how we utilize these advancements to alleviate suffering and cultivate compassion within ourselves and the world around us. The relentless cycle of creation highlights the need for balance, wisdom, and a deep understanding of our place in the vastness of existence.